Warfare has been defined for centuries by a central rule. The army that controls the high ground controls the battle. From Julius Caesar to Napoleon to Dwight D. Eisenhower, every major commander understood that holding the hills and ridgelines meant seeing farther, shooting farther, and defending more easily than the forces below. Over time, military strategy simply pushed that elevation higher, moving from mountaintops to aircraft, and finally to satellites orbiting 400 kilometers above the Earth. If you push that physical logic to its absolute limit, you find the highest ground in the inner solar system. Sitting 238,000 miles away, at the very peak of Earth's gravitational reach, is the Moon. The 20th century view of the Moon as a scientific museum is over. Defense analysts now map the lunar surface as the most contested piece of military real estate on the 21st century map. Superpowers are currently racing to occupy this territory for military supremacy rather than scientific prestige. Senior American officials have warned that China's lunar program targets specific strategic objectives that exist alongside its stated scientific goals. Understanding this coming conflict requires viewing space not as an empty void, but as a topographical battlefield map defined by these vital choke points. Earth sits at the bottom of a steep gravity well. Launching 1 kilogram of payload upward against that pole costs thousands of dollars in fuel, and that's only to reach low Earth orbit. This creates a massive physical asymmetry. Leaving Earth is expensive, but dropping a payload from the Moon requires almost zero initial energy. Because the Moon sits at a higher gravitational potential, Earth's gravity does the work, accelerating the object the entire way down. This mechanical advantage is the basis for a theorized tactic called kinetic bombardment. A dense metal rod launched from the Moon would strike the planet with the destructive yield of a small nuclear weapon. That impact energy is generated entirely from the velocity the object accumulates as it falls through the gravity well. After the initial launch, this projectile requires no propellant and no sophisticated guidance to reach its target. These orbital mechanics transform the Moon into a fortified firing position with an unhindered view of every point on the planet. This tactical map extends to cislunar space, the vast volume of the solar system stretching between Earth's atmosphere and the Moon. Current American radar and optical sensors are virtually blind to this region. A spacecraft maneuvering here could position itself to threaten infrastructure or establish a lunar presence with very little chance of being detected. The most valuable terrain on this map is the lunar South Pole. Inside its permanently shadowed craters lie massive reserves of water ice. Using electrolysis, electricity from solar panels splits water into hydrogen and oxygen, the components of high-performance rocket fuel. This creates a self-sustaining logistics base. Manufacturing fuel on site frees installations from Earth resupply, allowing them to fuel operations deep into the solar system indefinitely. The far side of the Moon offers a different tactical advantage. Because it faces away from Earth, its mass physically blocks all Earth-based radar. This makes the far side an impenetrable shield for staging stealth operations or conducting classified research away from adversary surveillance. The power that secures the South Pole's ice and the far side's stealth will set the operational tempo for all activity in near space. But as nations move to build these bases and claim these resources, the question becomes what international laws actually govern this activity. There is a significant legal vacuum. While the 1967 Outer Space Treaty bans nuclear weapons, it says nothing about conventional military bases, resource extraction, or the exclusive use of specific lunar territory. China and Russia are moving to exploit this gap, planning a permanent research station at the resource-rich South Pole by the early 2030s. America's Artemis program is the strategic countermove, designed to establish a U.S. presence at those same southern locations before its rivals arrive. Sustaining this presence depends on SpaceX's Starship. This reusable heavy lift vehicle can carry the massive payloads required to make long-term lunar operations economically viable. Because China rejects the American-led Artemis Accords, both superpowers are now racing toward the same craters with zero shared rules for engagement. Throughout history, strategic locations without clear legal governance, like the naval choke points that define maritime trade, have become the exclusive property of whichever power arrived first and had the capability to hold its ground. The nations that arrive at the lunar South Pole first will dictate the balance of military and economic power on the Earth below.